Hello everyone, welcome to this Eigen Library tutorial by Zebra Code. In this tutorial, we are going to learn how to download and install Eigen Library. We will also learn how to use the Eigen Library in C++ projects. What is Eigen Library? Well, according to their official website, Eigen is a C++ template library for linear algebra, matrices, vectors, numerical solvers, and related algorithms. We will actually see this in effect during this tutorial. Eigen is actually a pure header library file. You don't really need to install anything else for it to work. All you need to do is to include it to your project. Eigen is a pure header file library. An overview of the Eigen library on their official website shows that it is versatile, it is fast, reliable, elegant, and it has good compiler support. In this tutorial, I am going to show you how to download, extract the Eigen source code, and add it to a project. In order to use the Eigen library, you only need to download and extract the Eigen source code. Actually, the header files in the Eigen subdirectory are the only files required to compile any programs using the Eigen library. We will carry out some tasks during this tutorial. We will download the Eigen library from their official website. We will install the Eigen library. Actually, there is nothing to install. We can just download it, unpack it, that is, unzip it, then copy the main folder and paste it in our project. We will see that in a minute. Then we will create Eigen library based C++ projects. We will learn how to use some of the features of the Eigen library in our C++ project. To download the Eigen library, we can get it from their official website, which is right on the screen here. You can follow this link to get to their official website, or just do a Google search for Eigen library download. It will give you some results, and you can follow any of the links on your result page to get to the official website. However, to get to the official website, I will follow this link right on the screen. But before then, if you have not subscribed to this channel, please subscribe to the channel. By following that link, I am now on their official website. This is how the website looks as at the time of recording this video. And here it says Eigen is a C++ template library for linear algebra, matrices, vectors, numerical solvers, and related algorithms. There is a lot of information on their website, but for now, let's concentrate on how to download it. As at the time of recording this video, the latest stable release for Eigen is 3.4.0. You can download it from here. We have different options, and you can also clone it from the Git repository. I am not going to clone it. I am going to download the zip file. To download the zip file for Eigen, click on this option here, zip. Great. It has now downloaded the file. I am going to browse to where it was downloaded to on my system. Click the show in folder. Great. It was downloaded to the downloads folder on my computer. It is a .zip file. We need to unzip it. Right click on it. Extract to Eigen. I'm going to extract it. You can extract it to anywhere you like on your computer. Now I have the folder which has been extracted. It says Eigen-3.4.0. Now double click on it. Now this is how it looks. You can look at it to see what it contains. The folder that we actually need is this one here that says Eigen. Copy it, Ctrl+C. Now we need to create a project and paste it in that project. I have a folder here on my desktop which I created inside another folder, and I named it Math Work. I will be using Sublime Text as my IDLE or my text editor. You can use any text editor or IDLE of your choice. I have a project here which I named Math Work. This is the name of my project and this is the folder. You can give yours the same name or give it another name that you are happy with. This is the folder that we unzipped. Double click on it to open it. Now look for this folder that says Eigen. Let's copy it. Copy. Now we need to paste it inside this My Work project folder. We paste it here. Great. Now I have it inside the My Work project folder and it also shows here. I'm going to minimize this and minimize this. Now I have the Eigen folder inside my project. Let me move this a little bit. Let's have a quick look at what it contains. Click on it. And here we have some files inside it. Dense, Eigen, geometry, eigenvalue, sparse, and so on. I am going to close this for now. Let me minimize this. Okay. Now, let's create a C++ file inside our project. New file, and I will call it app.cpp. I will give it the name app.cpp. You can name yours whatever you're happy with. Hit enter. Great. Now, our file app.cpp is saved inside the My Work project folder. This time, let's add some code, including the header files. I'll start with include iostream, include double quote, Eigen, / dense. We are actually referring to this Eigen folder, and there is a file inside it named dense. That is our header file. If you are using any framework such as Visual Studio Code to do it, you would need to add something like this. Include Eigen / dense. In our case, we are not using any framework. We added it straight to our project, so we don't really need this line. This one is the right one for us to use because we just add the library to our project. That is, we add it inside the double quotes. Now it's int main return 0. This is just a normal C++ template file. Nothing so special in it at the moment except this Eigen library that we have added to it. Now for us to test our library, we need to add some code. Let's start off with the comma-initialization. I will leave a comment here. Comma-initialization. Let's use Eigen, namespace, matrix, 3f. I will explain this in a minute. norms 1, 2, 3, 4, 5, 6, 7, 8, and 9, semicolon. And std cout norms. Okay, what is happening here? We are using the Eigen library, and this is namespace for the Eigen library. See here, Eigen. What we are saying here now is matrix 3, that is going to be 3 by 3 matrix. The F here stands for the data type. This is for float, and this is a variable that we have just created from it. And now this variable, we are trying to enter this data. Now we are passing the variable norms this data, standard cout norms. So let's compile and run our code to see what the outcome is going to be. First of all, save it. I am going to navigate to where that file is from my command prompt, cmd. Okay, now I have just opened my command line, cd desktop, and cd my intro, and cd mat work. This is the folder path that I just navigated to, G++, run app, the app.c++. Hit enter. Okay, it was compiled successfully. Now let's run it. Run app. Hit enter. Great, it was run successfully. Now we actually have a 3 by 3 matrix. Because here we say Eigen matrix 3 has 3 by 3 and is of data type float. Here we have a 3 by 3 matrix. So it is working perfectly right. This shows now that we have been able to add Eigen library to our project successfully. But there is a lot more we can do with the Eigen library. I will leave a comment here for another task. Create. That is, create 2 by 2 matrix or 4 by 4 matrix and print the size. Let's just demonstrate that. Say Eigen matrix. Let's start with the 2 by 2 matrix. Give it a variable name price. std cout price dot size. What we are doing here is easy to understand. We are using the Eigen library here with the namespace matrix, and we added 2 here because we want to print a 2 by 2 matrix. We give it a variable name price. Now we are going to print the size of this variable price. Let's save, compile, and run our program once again. Great, it was compiled successfully, and let's run it. Exactly, shows here 4. So the size of that matrix of 2 by 2 is 4. Now let's change it from 2 to 4. Save it. Let's compile and run our program again. Great, it was compiled successfully. Now let's run it. Exactly, it was run successfully, and it prints here 16. So 4 by 4 is 16. So the 4 by 4 matrix prints size as 16. I'm going to leave a comment here for another task. So here, let's create a constant 10 by 10 matrix with a fixed value of 6. What that means is we will create a matrix of size 10 by 10 and it will be populated with a fixed value of 6. So everything inside that matrix will be filled with 6. Again, matrix S D. I will explain this in a minute. Games. Now, games equals matrix X D colon colon constant 10 10 6. And let's print it out. Yesterday, see out what? Games. What we are doing here is easy to follow. Here we are using the Eigen Library namespace, matrix SD. This is matrix, then capital X D. The capital S means that the size of the matrix is unknown. We don't know what the size of the matrix is. The letter D means the data type, which is in this case double. This one, F for float, and this one, D for double. Capital S means the size of the matrix is not known. It is unknown. In this case, with the size not set, it is unknown and it is a dynamic matrix. Whereas here the size was set. Here the size was set. But here we are not setting the size. It is unknown. It is dynamic. So now let's save our file, compile and run our code. Got an error message here. Matrix SD has not been declared. The cause of that error message is easy to understand. We have not actually declared matrix SD in our application. To do that, here we can say using Eigen matrix SD. Now with this added, that problem will go away. We should be able to run this piece of code now successfully. Let's save our work, compile and run it once again. Great, it was compiled successfully. Now let's run it. Great, it was printed successfully. What we have here is easy to understand. We have a matrix of 10 by 10. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, from here it's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or you can count from 0 to 9. So it is a 10 by 10 matrix and filled with a constant 6. That is exactly what we have done here. 10, 10, and what you have here is what is going to be filled with. If I change that now, for example, to 0, save it. Let's compile and run our code again. Great, it was compiled successfully. Now let's run it. Exactly. You see a 10 by 10 matrix, but everything in it is set to 0. So this is how you create a constant matrix with some fixed values. I'm going to undo this so that it becomes 6. Let's do another example. Let's say here, create a 4x4 matrix with a set value of 0. Again, I'll just say again matrix float 4 4, and let's assign it a variable name, my nums. My nums dot set 0 let's print it out. Std see out what? My nums. So create a 4x4 matrix. Let's correct that. Create a 4x4 matrix with a set of value of 0. So here again, we are using the library and the namespace again, and we create a data type of float here. We assign it 4, which means it's of data type float, and it's going to be a 4x4 matrix. This is the variable name we assigned it. Now that variable we have set it to 0. I set 0. This is a function inside the Eigen library. Now let's print it out, save it. Let's compile and run our code again. Great, it was compiled successfully. Now I'm going to run it. Great. Now we have here a 4x4 matrix set to 0. That is exactly what we asked our code to do. We can do more examples so that you understand it better. There is a lot more that we can do with the Eigen library. At the moment, we are just using the module dense from the Eigen library. This is the module we are using at the moment. There are many other modules, but let's concentrate on this one for now. I'm going to leave a comment here. There are so many functions that we can use from the Eigen library. Let's use some of them here. Let's say working. Working with functions. Let's use the transposeInPlace function here. Using the transposeInPlace function. The transposeInPlace function can be used to change row elements to column elements. And we will see that here. Eigen matrix, Eigen matrix F. Let's give it a variable and I will name it result. Results, and it's going to be a 4x4 matrix. Results. Let's enter some values. 8, 12, 17, 33, 39, 101, 20, 91, 36, 42, 55, 88, 10, 37, 27, 17, semicolon, std, colon, colon, C out. I will say here, this is the original matrix. Results. This is the original matrix result. Now we'll print out results. Std, end line. I'll leave a comment here. Now let's use the function transpose in place, and we are going to apply it to results. That will be results dot transpose in place, semicolon, std, C out, the new result after using transpose in place. Results std, colon, colon, end line. So what we have here is easy to understand. We are using the transpose in place function from the Eigen library. We have here the Eigen namespace from the library matrix, and the variable we name results. Results is a 4x4 column matrix, and here we entered some values. Now this is the original matrix. We print out here results, which means it's going to print out these original values. And now we have applied the transpose in place function to the results matrix. Now with the transpose in place are applied to the results matrix, the new results after using transpose will be printed out. Now let's save our code, compile and run it. Great, it was compiled successfully. Now let's run it. Great, it was run successfully. The result is this. This is the original matrix result. This is how it looks before we apply the transpose in place function to it. Now with the transpose in place function applied to it, this is how the new results look. What is happening here is easy to understand. Let me show you a diagram here that will make it clearer for you to understand. Let's move this one to the left. Okay, this diagram explains what we have here. Before, it was 8, 12, 17, and 33. Now with the transpose in place function applied to it, it is from row to columns. Now it has changed from rows to columns. 8, 12, 17, 13, row 0. It's now 8, 12, 17, 33, column 0. What we have here on this row is now on this column. And what we have on this row is right here on this column. Change from rows to columns. That what we have here is exactly what we have here. This is how you use the transpose in place function in the Eigen library. There is something more we can do. We can also use the Eigen library for some basic arithmetic operations. Now let's do some basic arithmetic operations. some basic arithmetic operations with Eigen Library. With this, we can use some functions as well. We can use the sum, prod, main, coef, mass coef, trace. As we can use the sum, prod, main coef, mass coef, trace functions. How we create a matrix here and name it scores. Again, matrix for the scores is going to be a 4x4 matrix. Now scores. Let's enter some values here. 12, 18, 21, 34, 98, 122, 98, 27, 38, 20, 31, 45, 38, 11, 49, and 51, semicolon. Now let's print it out. std cout all values in the scores 4x4 matrix. Scores std end line. The first thing we are doing here now is easy to understand. We are going to print out everything inside the scores matrix. Now let's use the functions. std cout is that for some function. Std cout result for some function of the scores dot sum std end line. Let's do the same for the prod function. std cout result for prod function scores dot prod std end line. Next one, std cout result for the next one is main result for main function scores dot main std end line. The next one cout result for this one is minimal coefficient main coef function std colon end line. The next one result for mass coef function scores dot mass coef std end line. we have one more trace, std colon say out result for trace function. Scores dot trace. Std end line. Before we compile and run our code, let me quickly go through it. Here we have a 4x4 matrix and it's named scores. Here we have assigned values to the variable scores, which is our matrix, and now we are printing everything inside the scores matrix. Here we are applying some basic arithmetic operations to the scores matrix. The first one, we are doing the sum of all the elements in our matrix. The second one, we are finding the product. The third one here, we are finding the mean. This one is for the minimum coefficient. This is for the maximum coefficient, and this is the trace function that we are applying to the matrix. Now, let's save, compile, and run our program. Before we run it, let's remove the new lines so that everything gets printed on the same line. Okay, now let's save, compile, and run our code. Great, it was compiled successfully. Now let's run it. Great, it was run successfully. These are the values that our matrix holds. Now, result for sum function is 713. If you add everything here together, you will get this value. Here, result for prod function, depending on your compiler, you might get a result that is formatted differently from this. That is for the product. Then, result for main function is 44.567. It also depends on the compiler setting. Result for minimum coefficient is 11. This one is easy to understand. If you look at it here, the minimum is actually 11. Then result for mass coefficient function 122. If you look at it here again, the maximum number is 122. So that is very easy to understand. Then result for trace function, this is 216. Now, let me explain these functions a bit further. The sum function, this one calculates the sum of all elements in a vector or matrix. That's what we have just done here. While the prod function calculates the product of all elements in a vector or matrix. The mean function calculates the mean average of all elements in a vector or matrix. While the mean coefficient function calculates the minimum element in a vector or matrix, while the mass coefficient function calculates the maximum element in a vector or matrix. The final one here, the trace function calculates the trace of a matrix. In other words, the sum of the diagonal elements. That is what the trace function does. So with this piece of code here, we have been able to do some basic arithmetic operations with the Eigen library. Now let's do something else. So far, we have been printing everything from our matrix. It is also possible to print certain elements of the matrix without printing everything. See here, printing individual element from a matrix. So to do that, Eigen. I'm going to create a 3 by 3 matrix, and I will name it goals. Now let's assign goals some values. 23, 54, 92, 49, 27, 39, 83, 96, 63, semicolon. Now let's print individual elements from our matrix. std cout goals, bracket open, bracket close, 0, 0, std colon end line. This piece of code is easy to understand. Here we have a 3 by 3 matrix with the name goals. Here we assign values to our matrix, and here we are going to print out individual values from the matrix. We are not printing everything, but we are going to print it individually. With 0, 0, you might be able to guess what it's going to print out. If you are not able to get correctly, it's not a problem. You will see it in a minute and you will understand it better. Now let's compile and run our code. First of all, save it. Great, it was compiled successfully. Now let's run it. Great, it prints out here 23. If you look at it here, 0, 0. What does that mean? I'm going to use a diagram to explain it better for you. Okay, so what we have here is easy to understand with this diagram. Our matrix is a 3 by 3 matrix. That is 3 rows, 3 columns. It starts from 0. It counts from 0. So here we have 0, 1, 2, which is actually 1, 2, 3. Here we have 0, 1, 2, which is also 1, 2, 3. So now we say here we are going to print out 0, 0. This is row 0 and this is column 0. So that is why we are getting 23. With goals 0, 0, we got 23. Now let's print out 27. To print out 27, you can easily look at the diagram here and tell what these two values should be. This is row 1, column 1. So if we say here now 1, 1, we will get 27. Let's try that. 1, 1. Save it. Let's compile and run it. Great, it was compiled successfully. I'm going to run it. Exactly, the result is 27, which is row 1, column 1. Now let's print out 63. To print out 63, we will now say row 2, column 2. So if we change this one now to 2, 2, let's compile and run our code again. Great, it was compiled successfully. Now let's run it. Great, it was actually printed correctly, 63. So to print 96 will also be very easy. That would be 2, 1. If you change this one to 2, 1, let's print it. Let's compile it. Great, it was compiled successfully. Now let's run it. Great, it was printed correctly, 96. So this is how you print individual elements from a matrix. This is just a 3 by 3 matrix. It could have been bigger than that, could have been 4 by 50 or 4 by 100. This is how you would print individual element from your matrix. It's also possible to use just one number here. If I say here 3, it will print something, but it will be difficult to actually tell where that element is in our matrix. Let's run this one. First, let's compile it. Great, it was compiled successfully. Now let's run it. Great, it prints out here 54. So let's look for 54 in our matrix. Where is 54? 54 is actually here, and we entered 3. So in this case, you may get some numbers that you are not actually sure of which exact location they are occupying in our matrix. If you change that number to 0, it will give you 23. Let's quickly do that. Let's compile it. Great, it was compiled successfully. Now let's run it. Exactly. It gives us here 23, which obviously is in the 0 position here. That's a row 0, column 0. That one is quite understandable. But with 54, it was a bit difficult to understand where exactly that element is in our matrix when we use 3. So the best approach is to use 2 numbers, one for the row and one for the column. The Eigen Library has many features. In this introductory tutorial, we have used just a few of them with the dense module. If you look at it, almost everything we've done so far is based on the dense module. There are many other modules in the Eigen Library. You can have a look at the modules inside the Eigen folder. If I expand it here, you will see many of the modules here. They include the Chomsky, core, dense, which we've been using, then eigen, eigenvalues, geometry, and so on. For example, if you were going to use the geometry module, you would just have to include it, like we normally do, include eigen / geometry. So now with the geometry module added to our program, we should be able to access all the functions and methods that are inside the geometry module. Next time we will look at some other modules in Eigen Library. I hope you learned something from this video. Please remember to subscribe to this channel if you have not already done so. Bye for now. See you in my next video.